Okay, guys, Unit 1B, days 3 and 4, we're going to solve equations, and that is going to be finding the zeros of an equation. So when we're talking about solving equations, all of our equations are parabolas, mostly in this class. And what we're doing is we set this parabola equal to 0, and then we find out what x is when y is 0. And that is finding out the x-intercept. So when does my parabola hit the x-intercept? If it does. So one we'll do right now is this one here, f at x or y is equal to 4x squared minus 9x plus 1. I've put that on Desmos already, and my solutions will be just here, which is just over 0 and just over 2. So those are weird answers, and if you say, well, how do you get those? Well, you get them by using the quadratic formula. So let's go back to the quadratic formula, which is right here. You don't have to memorize that for this class. You know that a is equal to 4, b is 9, nope, negative 9, and c is equal to 1. So we play around with this. We know this is a y-intercept. One other thing we may or may not figure out is that b divided by 2a, so the negative of that, is going to be our axis of symmetry. So if I have 9 over 8, our axis of symmetry is just going to be over 1, just slightly over 1. So that isn't that important for this class, but it's a good thing to know. So it's just over 1, and if you notice, this is just over 0, this is just over 2. Our axis of symmetry will be right in the middle here, around 1. So let's go back and figure out our zeros by using the equation. I have minus b, which is then plus 9, plus or minus the square root of b squared, which is going to be minus 9 squared, minus 4 times 4, which is a, and c is 1. I'll put it there even though you might not need to, over 2 times 4. Let's clean that up a bit. That's plus 9, plus or minus, let's do this in one step. 81 subtract 16 is what, 65? I hope it is. So that's that, all over 8. Now that's my final answer. I look at 65 and I say, is there a perfect square that goes into that? Can I find a number that goes into that to reduce this rational? So I start thinking about numbers like 4 and 9 and all these things. 65 though, 25 goes into 65, but not evenly. Or 5 goes into 65, sorry, but not 25. So you're left with this. This is about 8-ish, right? 64 is 8. So this will be, my two numbers will be, so this is your answer, but if you want to know what this is, you can throw it in the calculator. And if you do that, let me just grab a calculator right now. If I go 9 plus 65 root, now hit your equal sign, be careful. So that's 17 divided by 8, and that's just over 2, 2.13, and that was our first zero. And the other one, when you do that, this is just around 8. Okay, so that's 9 subtract about 8 over 8, so you got 1 over 8, which is just around 0, which is my second zero. So this is how you get your answers. This is the actual answer. If you want approximate roots, you can throw it in the calculator and get positives, get decimals. Okay, so that's that. If you want to move forward in this class, we look at this. Here is my axis, set of axes. I can have parabolas that open like this. I can have parabolas that open like this. I can also have parabolas that do this. No, they don't do that. They have a vertex that is resting on the x-intercept. These guys have no zeros. These guys have 2 zeros. These guys have 1 zero. Or another way we talk about these have 2 identical roots. This guy here has 2 different roots, so I have 1 and 2. So roots, x-intercepts, all the same thing. And the way we know this is by using the discriminant. And this, you probably knew this, but now we're going to make proof. So this part here is under the root sign. This is called the discriminant, b squared minus 4ac. And if you ask yourself, what's the square root of a number that's a positive number, like 16 or whatever, it's going to be a big number. So even like 21. 21 is not a whole number, but it's somewhere between 4 and 5, so it's 4 point something. So all of these have answers. Then you have 0, that's a different case. Square root of 0 is 0. And then you have another case, which is the square root of a negative number. So whatever that is undefined. So when I'm trying to figure out the roots, how many roots there are, if I have a positive number here, under here, then I'm going to have, when I get to this point where I'm adding and subtracting, so the negative b plus or minus something, whatever this something is here. If it's big, then I'm adding a number and then I'm subtracting a number. Then I have 2 different roots. So if this guy is greater than 0, I'm going to have something added to it and something subtracted from here. And I have two different answers, which means I have two roots, which is this case right here. If under the discriminant, under the radical or the root sign here, my discriminant is equal to 0, then I'm going to add 0 and subtract 0 from my equation over here. And if that's the case, I'm not doing anything different. I'm just going to have the same answer twice, and I'm going to have one root. If this is a negative, b squared minus 4ac is a negative, then when I put that in the calculator, the whole thing falls apart, and it says undefined, and then I start crying. But the truth is, it's less than 0, and if it's less than 0 or negative, then there are no roots, and that's fine. You could have no roots, right? I can have an equation that starts up here and stays up here, never crosses here, and that's totally fine. So discriminant, greater than 0, 2 roots, equal to 0, 1 root, less than 0, no roots. One little, and then we get to the fun stuff. We have questions like this. If my equation is this, x squared minus kx plus 2, just make that up, is equal to 0. What is the value of k? So I have a certain amount of roots. So what is k? Let's just say this. What is k equal to? So I have 2 roots. And that's all about the discriminant. Okay, so 2 over 4ac. There's my discriminant. A is equal to 1. B is equal to whatever's in front of the x. And in this case, B is equal to negative k. And C is 2. So when I get my discriminant here, if I want to have 2 roots, I need this to be bigger than 0. I need the discriminant to be bigger than 0. So let's put in what I have in here. So that is this, and then this is this. 4ac is 4 times 1 times 2. So 4 times 1 times 2, I'm just subbing in. So now I'm going to come back and say that k minus k squared, which is k squared, subtract 8 has to be greater than 0, or k squared has to be greater than 8. So as long as k squared is greater than 8, then I have 2 roots. Okay, so I solve for k in this case. And that's about it. More questions like this. If you do have a situation where you have something like this, negative k is greater than 3. This is just an aside here. If negative k is greater than 3, so let's think of our number line here. Negative k is greater than 3. So let's think of numbers that works for. So here's 0, 1, 2, 3, 4, 5. If negative k is greater than 3, then k itself is a big number, but negative, right? So k itself is going to be 1, 2, negative 1, negative 2, negative 3, negative 4. So think about that for a second. If k, where's this true? Let's try if k is equal to negative 4. Is that true? Well, negative 4, is that greater than 3? Well, negative 4 is 4. That's greater than 3. So yes. So I want the numbers on my number line that are way over here. Big negative numbers. So when I solve this, if you look at this and say negative k is greater than 3, and you want to figure out what k is, you're going to divide each side by a negative, right? And when you do that, you're left with k and negative 3. But if you look at this and you say k is greater than negative 3, well, k is greater than negative 3 is all these numbers. Oops. How did I do that? Amazing. There we go. K is greater than negative 3 is all these numbers, but I don't want these numbers. I want the numbers that are way down here. And to get those, I need to change this sign. So anytime you multiply by a negative or divide by a negative, when you have an inequality, a greater than sign or a less than sign, you need to turn this thing around. Okay, so that's just a small rule that you got to keep up with. And that's it for Unit 1.5. We'll do determining equations next. Take care.